Finally, OpenAI did something open, and it actually looks pretty impressive. That's right, they dropped two new models today. We have GPT OSS 120B and GPT OSS 20B. These are two open weight reasoning models with an open source Apache 2 license. This is the first open model from OpenAI since GPT-2. They claim they're going to outperform similarly sized models on reasoning tasks, so look out Qwen and DeepSeek, and they actually come close to their own O3 model. So let's see what these models are. I'll run one of them locally, I'll give them a few coding challenges, and I also want to take a look at whether they are those Horizon beta models that we saw stealth launch on OpenRouter. I saw a few people saying that they might be, and also some saying they might not be. Then at the end of the video, we'll also talk about the official benchmarks. Starting with GPT OSS 20B, this is obviously that 20 billion parameter model, and it has a context length of 128,000 tokens. Apparently, it delivers similar results to O3 Mini, and it can run on edge devices with just 16 gigabytes of memory. This makes it perfect for on-device use, local inference, or rapid iteration without costly infrastructure. That is absolutely insane. This means that I can get it up and running on my MacBook. Literally all you need to do to run this, by the way, is just download Llama, and they already have the options for GPT OSS in the selector. I can't run the 120B model on my MacBook, but I can certainly run the 20 billion parameter one. Once you select this, it will need to do a download. It was only 12.8 gigabytes. Once we've done that, we can start chatting to GPT OSS 20B completely locally. I'm going to start out with a quick test by just asking it what model it is. And you can see it's actually really fast at returning a response. It thought for 2 seconds. It simply just went over the thought process of what exactly I asked it. And you can see this is definitely going to lie about what model it is. It doesn't actually have that in its data. You can see it claims that it's GPT-4. I've moved over to running Llama on the terminal here, so it should give us some information about the tokens per second. So if I ask it what are black holes, you can see really quickly that we're getting a response there. It is actually super fast. And once it's done explaining what black holes are, you can see down here some of the information. We have the total duration was 31 seconds, the load duration was 47 milliseconds, we have a prompt eval rate of 134 tokens a second, and the overall eval rate of 36.47 tokens a second. This is actually really fast for a model that is running locally on my MacBook. I've also seen that some of the providers, when they give this way more power, have actually got it running at 3,000 tokens a second. That is absolutely insane. The next test I'm doing with 20B is the classic Polygon container. We have a load of bouncing balls inside of it, and you see whether it can deal with the physics of actually keeping it inside of the Polygon. As you can see down here, it actually thought for 38 seconds, and at the moment it was still generating my HTML and JavaScript. We can see it in this long file here, and it's still going with it at the moment. Seems like it's moved on to the UI part now, and my MacBook is getting a little bit loud now, and it's finally complete, so let's test it. On initial load, we do get our polygon here, and you can see we have the bouncing balls inside of it. At the moment, everything is paused, and we also have our sliders up here so we can configure things like the gravity. If I go ahead and unpause this, we can see the polygon moves, and then the ball, they went to space apparently. I have no idea what's just happened there. So they're off in space, and now my polygon is in space, or I think it might be there, but for some reason, it's now just lowering its opacity. Have no idea what's going on with that. But you do have to remember, this is quite a complex prompt, and this was completely locally generated on my MacBook. That is absolutely awesome. I could use this on a flight now when the Wi-Fi is absolutely terrible. It does also nicely transition me into GPT OSS 120B. This is the code that I generated with the 120 billion parameter model. As you can see here, we do have our polygon. The balls are inside of it. Some of them seem to apply to physics. Some did manage to break out there. But overall, I'd say this is a much better result. Now, if we compare this to Horizon Beta that I saw on OpenRouter, I saw a couple of people use this prompt, and the UI doesn't actually look that similar. It seems like the Horizon Beta models were really good at UI, and I don't think they're the GPT ones. So I'm really curious to find out who actually made those Horizon models that we saw on OpenRouter. But back to GPT OSS 120B, this is obviously that 120 billion parameter model, and they say it achieves near parity with O4 Mini on core reasoning benchmarks while running efficiently on a single 80 gigabyte GPU. That means if you have a good enough PC, you can get a local model running that is close to O4 Mini. That is actually insane. They do also mention that you could get this running on a high-end laptop. Seems like the only one that's actually capable of that is the high-end MacBooks, which cost 5,000 Great British pounds. Unfortunately, I don't have one of those, so I'm going to run the model through OpenRouter, and the price there is actually crazy, but in a good way. It is 15 cents for a million input tokens and 60 cents for a million output tokens. I'll take a look at the models in OpenCode then. You can see down here I've activated OpenRouter GPT OSS 120B, and this was actually the Polygon prompt that I gave it earlier, but I just want to show you how fast this is. You can see it streaming in there. The tokens per second are absolutely insane. And I imagine it's probably going to be hitched up at the moment because a lot of people are hitting this model, but it is super fast anyway. Enough of the polygons though, we already saw the result and it was actually quite impressive. What I'm going to do is I'm going to give this a Next.js project that has a backend, and I'm going to say look through the existing project to understand the structure, create a personal finance management dashboard that offers a load of things like detailed overview, financial goals, and all of that, and I'm just going going to let it get to work and see how it does. I've got some bad news. I cannot get it to work. I've gone back and forth in OpenCode here with the error message that it gives me a few times, but for some reason it's really caught up on how to use TRPC and doesn't seem to know how to use it correctly. And I've tried to paste in the error message and get it to work itself out, but it looks like it would require a lot of manual intervention. You can see the code that it did generate here. Obviously, we have a few types, and then we have the page.tsx for our finance dashboard. It didn't seem to want to use just any React components. It just made it all in one here. So you can see it's got the account section, transactions section, and as I said, it didn't create any components for any of this information. It just shoved it all into a single page.tsx. And then on the back end here as well, we have create TRPC. And as I said, this is just really struggling to get TRPC working. So maybe I gave it a prompt that it was a little too over-eager. I did include the front end and back end. So let's try a little bit of a different one and just get it to mock a front end. I'll try again then, the exact same prompt, but I'm just going to say mock the front end this time and don't deal with any of the back end. This time it did a little bit more. Obviously we have our mock front end here, but I'm not really that impressed with the way that it looks. I did see some of those Horizon models were doing really nice UI. I definitely don't think the GPT OSS is the Horizon beta models on OpenRouter. So my results there are a little mixed. It did alright on the Polygon test, the 120B model, but then it seemed to fail when I used it in OpenCode to try and ask it to look through my project first and understand the structure of it, and then add to it with its own financial dashboard. As we saw, the React that it was writing wasn't really great React. It wasn't using components or anything like that. But then when we switched it to just mock the front end in index.html and with Tailwind, it seemed to do okay. The financial dashboard didn't look great, but it wasn't too far off what I got from Claude Sonnet 4 here. As you can see, it does look a little bit similar. Claude Sonnet 4 one does look a tiny bit better, but for the price difference, I'd say that's actually quite okay. But I don't think it will be replacing Claude Code and Claude Sonnet 4 for me anytime soon. Obviously though, you do have to remember these models are open and you can get the 20B one running locally, and that is absolutely awesome. There are tons of uses for that. We just want to test out an AI. You can spin one up locally and it will actually give you semi-competent answers. But obviously those were just my coding tests, so let's jump into the benchmarks and see how OpenAI say that it performs. I'll start out with the Code Forces benchmark, where the 120 billion parameter model scores 2,622, just close to beating O3 and actually beating O3 Mini. The 20B version actually beats O3 Mini as well, and again is very impressive with 2,516. From what I could tell, the 235 billion parameter Qwen 3 model only actually scores 2,056 on this, while the 32 billion parameter model scores 1,922. So it seems that GPT OSS might be a little bit better at coding than the Qwen models. For the non-code benchmarks, in math on AIME 2025, the 120 billion parameter model scores 96.6%, with 20B actually scoring closely behind with just 96%. Funnily enough, both of these models actually outscore O3 and O3 Mini. On GPQA Diamond, the 120 billion parameter model actually beats O3 Mini, and it does near O4 Mini, but doesn't quite top O3. The 20 billion parameter is actually a little bit behind here at 71.5, but this story also continues for the rest of the benchmarks that show the 120 billion parameter model is close to O4 Mini levels of intelligence, and the smaller one does near O3 Mini. But remember, these are all open models, so that is pretty impressive. If you want detailed benchmarks from that paper, pause the screen here, because I've said about all of the acronyms that I can say in a day. There we go then, they finally put the open back in OpenAI. What do you think about this? Are you happy they finally did this, and will you try out the models? And if you have already, how did you find it? Let me know in the comments down below. While you're down there, subscribe, and as always, see you in the next one.